In this video, what we're going to look at is some of the forces and pressures that create fault lines, create things like the Alps in the South Island and that sort of thing, and the fault lines that cause earthquakes in New Zealand. The first thing we need to understand is about things called convection currents, which are formed when you've got a difference in temperature. So what I've got here is a beaker of warm water, and of course above it is cold air. Not that cold because it's a hot day, but it's definitely colder than the water that's in it. And to show you that those water particles aren't staying still, I'm going to put a little bit of food colouring in there. And we're going to see what happens to that food colouring when I put it in. Now the food colouring is cold, so it will drop because it's denser than the water. So it will initially start to drop. But then as it drops, it heats up. And as it heats up, it starts to spread out, which is called diffusion. That's not part of this learning. But you'll notice that some of the particles are starting to go up again as they heat up, because hotter particles are less dense. This creates a little current called a convection current. So you can start seeing it forming around here where the water particles that have got the dye in it, or the food colouring, are starting to go up again. What this creates at the surface is this sort of motion. It's where it's going up and then to the side, up and to the side. Now if this was very dense, like the rocks, the liquid rocks in the mantle of our Earth, that would mean that the crust that sits on top is being pushed and pulled around by these convection currents. When this happens, it makes the Earth's crust break up into sections. Can anyone remember from yesterday what those sections are called? Yep.
Tectonic plates.
Tectonic plates. Awesome. So they're the bits of the crust, the big bits of the crust that have got cracks in between them. They've broken up because these convection currents are pushing and pulling the crust pieces apart and towards each other. So what that does is creates movement of these plates, which has formed a lot of countries to form in certain features of countries. India, for example, used to be down by Antarctica. But because of these convection currents pushing and pulling India and Asia around, India ended up crashing into the Asian continent, creating the Himalayas. And the way that it did it is when they pushed together, it folded up like a bit of cardboard. And that made the biggest ones in the world. Now I'm going to go over the other side to show you the next bit, what happened in New Zealand. In New Zealand, we are on a thing called a subduction zone, which is where one plate, the oceanic plate, goes underneath, because oceanic plates are a little bit less dense, goes underneath the continental plate. And the continental plate we're on is the Indo-Australian plate. So it's not got our name in it anywhere, sorry. It's sometimes called the Australasian plate, that's not quite right. And what's happening is they're not just coming together like this, they're going on a bit of an angle. And at the same time, because we're on a plate boundary, all of this heat is creating pressure. And I'm going to show that by scrunching my fingers together while I do this. One plate's moving this way and one plate's moving this way. So they're not going straight towards each other. And you might be able to see what sort of thing might happen. Okay, so I'm scrunching my fingers because there's lots of pressure there from underneath, and I'm pushing them together, and it makes this fold. And these are called fold mountains. What mountains on the South Island do you think they are? We sometimes call it the Alpine Fault, this big one here. So what are those mountains? Southern Alps, perfect. So this is probably Mount Cook here, the biggest one, and then it will get smaller again over here. Okay, so as we go away from the screen, it'll get smaller. What do you notice is being formed over here? All these little cracks and creases. What do you think they are?
Ridges.
They are ridges in the cardboard, but what do you think they are on the South Island? They're not rivers, they're little mountains, or we learned about them yesterday a little bit, and it's our goal for Wednesday. Fault lines or faults, good. And notice they don't all go the way that the two plates are meeting. They come off on the side and little bits over here, and actually because of the pressure, sometimes you have some forming like that are nowhere near it. Now, is Christchurch near the Southern Alps, or is it quite far off the Southern Alps?
Quite near.
It's quite near. It'd be around about here probably. But there's no fault line, big fault line or mountain range going through Christchurch, is there? Okay, so it must be due to the pressure underneath creating these other little creases or faults. And then these can slip when the pressure builds up too much. What do you think happens when the pressure builds up too much from our convection currents in the mantle, our hot mantle? What do you think happens when the pressure builds up too much under one of these areas where it can escape, which is a fault line? Cool, it can cause an earthquake and then it's aftershocks that come after that. Good. And that's what we experienced in Christchurch in September, and then a different fault line off to one side in February that was a bit more aggressive than that one. What can also happen, do you think? And this, if anyone lives out Littleton might know about what else can sometimes be made instead of an earthquake. What happens is that it all escapes another way. Tsunami would be one if we had one out here and it makes a wave. Good. So I don't think it's on the screen, but if it was off the land, you'd probably get a tsunami. So that would be an earthquake as well. Volcanoes. Sometimes the pressure builds up. I can't do it with cardboard because it's too thick. But it breaks through and it pushes up and up and up and up, making a volcano. Just like around Littleton where we've got a volcano, it's blowing, and then Littleton Harbour is what's left over from that, a thing called a caldera. Basically the crater has become filled with water, and then it's corroded away enough in Littleton that it's become part of the sea. So we get, just to rewind, we get movement called convection currents because the mantle is hot and the crust is cold. So it pulls the hotter particles up and they push outwards, and that pulls things apart or pushes them together. The things that it's pushing and pulling are called plates, tectonic plates. Where those tectonic plates collide, all that pressure, if they're colliding, can create fold mountains because this is a subduction zone. And because of the pressure, you get fault lines off to one side as well. And these fault lines can cause earthquakes, and these regions of pressure can create volcanoes. Any questions before we stop the video? Okay, I'll get someone to press the video button on there for me, please.